In this video, we'll talk about a few things related to inheritance. Every data type in C# inherits from the object class. So as we can see here, this is a class give us methods like toString, get hashcode, and so on. When we create a new class in C#, it automatically inherits from the object class. Now suppose we want to create two classes, an account class representing a bank account and a CD account class, which represents a special type of account. CD account inherits from account, and we would call CD account a subclass of account. In Java, we call account the superclass of CD account, and in C# it's called a base class instead of superclass. Here's what the account class looks like in C#. We have a couple of properties, ID and balance, a constructor, and a couple of methods, deposit and toString. I highlighted a couple of keywords we haven't seen before, virtual and override. We'll talk about them in a moment. This is the CD account class. It inherits from account and has an additional property term, representing the term of the account. Notice the syntactical difference compared to Java. In Java, we see a class extends another class, but here it's just column. In Java, we call account a superclass, and to call the constructor of a superclass, we would have super at the beginning of the constructor. In C#, account is called a base class, and calling the base class constructor would put it in the constructor header like this. We actually saw this syntax in the last video when a constructor calls another constructor. If we want to call a method in the base class, it will be base.methodName as opposed to super.methodName in Java, but otherwise they are the same thing. So what about the override and the virtual keywords? Well, first we need to brush up on the concept of override. Override means a subclass re-implements, or in other words, changes a method defined in the base class. Override is very much related to the so-called polymorphism. Take this as an example. Suppose we have an account array. We can create an account object and assign it to the first element in the array. And we can create a CD account object and assign it to the second element. Here's the first part of polymorphism. Notice that accounts1 is actually a base class variable, but nonetheless we can assign a subclass object to it. This is a good feature to have because we can put all kinds of accounts together and use the same code to manage them instead of handling them separately. But what if a method is overridden in a subclass? For example, if we use console writeLine to print out these two objects, the code will call the toString methods of the two objects to convert them into strings. Note that the account class and the CD account class have different toString implementations. Here, in the account class, it prints account toString method. It converts it to a string that has account ID and balance. And here for CD account, it converts it to a string with CD account, ID balance, and the term. So in this code, the first write line will call the account_toString method for sure. But what about the second one? On one hand, account1 is an account variable, so it seems like it should call the account_toString method. But on the other hand, this variable does point to a CD account object, so maybe it should call the CD account_toString. Let's run the code and see what will happen. Let's first copy over the account class. Let's put it here. And the CD account class, let's put it here. And this part of the code, and let's put it here. So if we run this code, we can see that the first write line uses the account_toString method, and the second one uses the CD account_toString method. We can see that indeed, for the second write line, the CD account_toString method is called, and this is the second part of polymorphism. We can use a base class variable to reference a subclass object, but the language is still smart enough to know that it's actually a subclass object, so it will use a method implementation in the subclass when needed. In C#, we must use a virtual keyword to indicate that a method can be overridden, like the deposit method in account class. And we must use the override keyword to indicate that a method is overriding a base class method, like the toString here and both deposit and toString here. This behavior is quite different from Java. In Java, if a subclass method has the same signature as a superclass method, it's automatically considered overriding the subclass method. So what happens if we don't specify the override keyword? Well, then in C#, the subclass method would hide the base class method, and this is known as shadowing. Shadowing can be made explicit by using the new keyword. And in any case, shadowing affects polymorphism, like what we can see in this example. So if instead of overriding the toString in CD account, we say new, meaning that it shadows or hides the toString method of the base class. Then if we run this code again, we can see that the write line method no longer invokes the toString method in CD account. It will simply treat the second account as a regular account and call the toString method in the regular account. In other words, it's no longer polymorphism as we typically want it. Because we almost always want polymorphic behavior, overriding is much more common than shadowing. Another term that sounds similar to overriding is overloading. Overloading means a class may have multiple methods that have the same name but different signatures. For example, we can have add methods that adds two integers And we can have another add method that adds two double values. In this case, we can see the method name add is overloaded. In Java, we can only overload regular methods, but in C# we can actually overload operators like plus, minus, multiplication, and so on. And this sometimes makes the code look nicer and cleaner. Let's see this example where we overload the plus operator for depositing some money to our account. Notice that we already have a deposit method, so this is just for example, and we'll use our operator to deposit money into our account. To overload an operator, we must create a public static method, so it has to be public and static. And like a typical method, it will have a return value. This is the result of the operation, and we specify the type of the return value or the result here. And then instead of saying method name, we will say operator and then the operator we are overloading. And then, like a regular method, we specify a parameter list, and this parameter list will be the operands for the operator. So let's take this and actually implement it. We'll put it in the account class, and we need to actually implement this. So what we do is to add this amount into the account. So we can simply say deposit this amount to the account, and it needs to return a value as the result of the operation. So we'll return the account itself. So now we have overloaded the plus operator, and then let's see what happens. We'll do accounts 0 plus 50, so depositing $50 into this account, and now it should becomes 150. If we simply write code like this, C# would complain, and it wants us to use a variable to hold the result of this operation. Otherwise, it won't allow us to just write this like this. So we don't really need the result because we know that the data is the amount is deposited into this account. But since C# wants us to have a result, we can use something like this. So this underscore is called a discard in C#. It's basically a dummy variable that we can use to set the result of some operation, but we simply tell C# that we don't really care about it, so it's called a discard. We just use it as a placeholder and discard it afterwards. So after that, if we run this code, we can see that account 0 now has 150, and this plus operator indeed works. Another nice thing about C# operator overloading is that if we overload plus or the minus operator, we automatically get plus equal and minus equal. That means we can change this code to be to this, and this will still work. Let's change this to 60 and run it, and now the first account has 160. So this is how operator overloading works in C#. As I mentioned, sometimes it makes the code look nicer and more concise. So that's a good thing. Like in Java, we can create abstract classes in C#. An abstract class is a class that has one or more abstract methods, and the abstract method defines the method signature but no implementation, like this one. A subclass of an abstract class must implement the abstract methods, unless of course the subclass is also an abstract class itself. Because abstract classes have quote-unquote missing pieces, we cannot create objects from an abstract class, but they are still quite useful in certain situations. For example, like in this case, suppose we want to create a library that handles all kinds of different shapes like circles, rectangles, triangles, and so on. We can put their common properties and behaviors in an abstract class like center and move, and all the actual shapes can inherit from this abstract class, and they only need to implement their specific behavior, like how to draw that specific shape. A concept close to abstract class is interface. An abstract class can still have some concrete things like fields and actual methods, but an interface can only have abstract members. Interface is widely used in modern object-oriented programming languages because it's perfect for describing API. In C# naming convention, the name of an interface usually starts with I, like this iDrawable interface. Notice that interface members don't have access modifiers because they are always public. Like in Java, a C# class can inherit from one base class, but it can implement multiple interfaces. In Java, we would write something like rectangle extends shape implements iDrawable, iColorable, and so on. But in C#, it's just column for both base class and the interfaces. By the way, you can see this is why in C# naming convention, interface names would start with I, because otherwise it would be difficult to tell which one is a class and which one is an interface in situations like this. Okay, we'll stop here. Inheritance-related things are covered in Chapter 6 of the Pro C# 9 book. Please check it out. Thanks and see you in the next video.